Hi, I hope that you're well. So what I want to do in this presentation is just tell you a bit about A-level physics, what you can do with it, what's it all about. The A-level physics course is really quite beefy. You'll get a few weeks into it and kind of look at how far you've come in terms of your ability to deal with equations, to rearrange equations, to solve problems, and just be amazed at the amount of progress that you'll make in the first 2 or 3 months. So in physics, we look really at matter and energy. So matter in terms of things like projectile motion, the work of Galileo, things like electricity, we look at in some detail. We look at photoelectricity, which is one of the things that Einstein won a Nobel Prize for. We look at waves and the relationship between waves and projectiles, particularly when it comes to photons. In year 13, we really get into some quite detailed physics. So we do fields, for example, gravitational fields, the work of Newton. We look at particles, the idea that you don't just have protons, neutrons and electrons, but looking at the stuff that makes up this, quarks, leptons. We look at nuclear energy in some detail, how it is that fission works, how it is that fusion works. Medical physics, MRI scanners, CAT scanners, X-rays, ultrasound. We look at quite a bit to do with other types of fields, so magnetic fields, electric fields, and we also study quite a nice amount of astronomy, so have a decent look at how it is that that stars evolve, have a look at how it is that we know what it is that stars are made up of, how it is that the universe has expanded from the first 10 to the minus 35 of a second to how the fate of the universe will be. It's a really nice, rounded, detailed look at all of physics. I actually spoke quite a bit about this in the last slide. So you can see the different things that we cover. The specification, OCR, yeah, very popular specification. There isn't much between the different A-level physics specifications. They all cover the same stuff. We'll get you doing as much practical as we possibly can. In particular, everybody should gain the practical certificate to say that they've completed all the compulsory practicals and all of the different skills that they need to get. But really, I've kind of already talked about the different parts that that are involved in there. So you get examined at the end of year 13 with 3 exams, and they add up to the customary 6 hours per A level. So exam paper 1 is called modelling physics. It's on half of the year 12 work, in particular projectiles and materials, and it's on half of the year 13 work, thermal, circular, simple harmonic motion, gases, gravity, astronomy. Exam paper 2 is on the other half of year 12 work, electricity, waves, Einstein's photoelectricity. And on the other half of year 13, so the other fields, medical physics, nuclear physics, particle physics. And then the final paper, exam paper 3, unifying physics, is the whole lot being examined at once. Expect at the end of year 13 to have these exams over a period of about 2 weeks. So you can focus on exam paper 1, then have a few days off to refocus on exam paper 2, and then draw the lot together in exam paper 3. Also expect there to be some multiple choice questions in there right at the start of each paper. Expect there to be quite a lot of calculations. 40% of the marks will be mathematically based. The things that we need to do really well at, and which I'm quite sure that the people taking the course will do really well at, is explaining kind of longer answer questions where you get given quite a detailed physics phenomena to explain, and you have to look at that in some detail. There is no shortage of careers for you to use physics in, no shortage at all. It works particularly well with the engineering disciplines, with mathematical disciplines, with computing. It also is quite attractive these days to the financial markets and to software development, because the sort of skills that you learn in physics are used in those situations. Weather forecasters are physicists. Military, it's very popular in the military, and you know, not just because, I mean, some instances in the military they will look specifically for a physics role. For example, if you're running the reactor on a nuclear submarine, but also, you know, more widely in the military, I've had a student who was doing physics A level to become a fast jet pilot with the RAF. Um, Clearly, the usual physics routes. It's also very useful for the academic research. But I think the point here, where I said that there's no career where an A level in physics will be, you know, not rated highly. As you know, I didn't work in physics for a number of years, and whenever somebody found out that I was qualified in physics, it always was, you know, it quite impressed them. It is an A level which does impress people when you've won it. In terms of people who have gained a physics degree, so Jonathan Edwards, not as well known these days. He used to be a triple jumper. He went to Van Mildert College in Durham. Neil Ferguson is quite well known at the moment. He is a statistical modeler who uses data about how well COVID is spread to forecast how the disease will spread and what we can do to prevent its spread. He did physics at Oxford. Dara O'Brien, we of course know. He did theoretical physics with an awful lot of mathematics at University College Dublin. Angela Merkel, the Chancellor of Germany, she did a degree in physics at Leipzig University. She then went to Berlin. Her research interest is in quantum chemistry, so the kind of borderline between the two. Again, I don't think a degree in physics has held back any of these people, and especially for Neil Ferguson, you know, the science that he learnt there about exponential growth, about modelling, it's a good example as to how physics can be applied elsewhere.